All right, welcome back. Lesson 2, part 4. Okay, so I'm going to calculate on a calculator 8 decimal 512 thousandths and 3 decimal 807 thousandths on a calculator. And what I'm going to come up with is this number here. Does this answer make sense? What whole number is going to be close to this number here? Well, that's going to be 9. And which one is going to be close to this number here? And that's going to be 4. So if I want to check to see if this makes sense, I'm going to multiply these together. And 9 times 4 is going to be 36. Is our answer close to 36? Yes, it is fairly close. But I think that we can get a little closer. And then how we do that is by taking one of the numbers and making it higher, so 9 times, and making the other one lower. So instead of 4, 3. And this is going to be 27. Okay? Then I'm going to do the opposite. So I'm going to make this one lower and the other one higher. And that's going to be 32. Now, I knew this number was going to be higher than this because I rounded both of these up. If I round this one up, notice that the 512 thousandths is kind of equally distant from both sides, from 9 and 8. But if I round this one up, this is definitely already closer to 4. So it makes more sense for me to round this one up and to round this one down, which would make sense to have it equal closer to the actual number. Okay, so if I have 3 decimal 74 hundredths and 23 decimal 1/10ths, and I'm looking to find where the decimal point goes here, okay, rounding is going to help me. So where can I place the decimal point so that the number is closest? So I would go 4 times 23, right, and that is 92. So that would put me right in here. Now, rounding to the leading digit, instead of the nearest whole numbers, for example, 4 times 20, okay, and that's going to give me 80. And this is a good estimate. It'll lead you to putting the decimal in the right spot, which is easier to multiply then. So if they're both good estimates, they're going to lead me to the same spot. Which one is easier to do? Well, clearly this one is easier to do because it requires only single-digit multiplication. When there are 2 ways of getting the same answer, we might as well pick the easiest one, right? Okay, so I'm going to skip that one. Okay, so I have 7 decimal 985 thousandths and 26 hundredths. Okay, so this is my answer. I'm trying to figure out where to put the decimal. Now, I know that the answer here should be about a quarter of 8, right? Because if I round this, right, and this is about 1/4. So if I round it to the nearest whole numbers, what's going to happen is that's going to become 0, and then it makes it really difficult for me to estimate. So it would make me have to put a 0 in here, right? Which is not where the decimal is going to go. So rounding to the nearest whole number gives the wrong answer here. Instead of rounding to the nearest whole number, you should round to the leading digit, which is going to be this 2. So I would actually be multiplying by 3/10. So 8 times 3 is going to be 24, and the decimal is going to go in here. So I know that when I'm estimating that my answer should actually have the decimal point in here after the 2 and not before. So just be aware of that. If there's a first leading 0, you're going to round to the first non-zero digit that comes from the left. And that will help you. All right, so I have 3.74 times 23.1, and it equals 86.394. Now, if I count these digits in the decimal places and I had multiplied, I could very well just hop these over and that ends up with the right answer. But this one has ended up with the wrong amount of decimal place values. And that is because when we multiply this, if we were to do this, if we do this on a calculator, it's leaving off that ending 0 because 5 times 4 is 20, right? So it's leaving off that ending 0. So that is something that we also need to be aware of. If we put that extra 0 at the end, then it would show that place value. All right, so that is the end of this session. Please go and finish your work.